Hello, this is Tuesday's lecture for week 15. I'll be doing a walkthrough of Lab 11, which is due next Tuesday at 8 a.m., which happens to be our final exam time. So it's not a coincidence, as you'll see, this is very closely related to what I'll be asking you to do on the final. So if you would go to your assignments tab, you'll see that Lab 11 hand assembly is there. And if you the instructions are actually reproduced on the spreadsheet itself. So if you go to Resources tab and then Labs, where is it? There it is, Lab 11 hand assembly. So you open this up and this takes you to the spreadsheet. Right here. And on the first pages of the spreadsheet, you'll see the instructions, but I'll go ahead and say those now. In these yellow highlighted fields, these are the cells in the spreadsheet that will be changing during each operation. So these are the ones that I'd like you to update. And we'll just be walking through page 235 of the Petzold text, where he shows you how you would do a multiplication program using the assembly language that is described in chapter 19. Now, I've summarized the assembly language notes from chapter 19. You can see these also in the resources tab, lecture 18 for chapter 19. But I think that you'll find it's pretty intuitive. What we've done, instead of using the machine language codes for load, add, store, subtract, add with carry, subtract with carry, we've actually have these three-letter mnemonics. So it's much easier to remember that ADD means add rather than 2, for example, right? Or it's much easier to remember that LDA means load into the accumulator rather than using 10 in hexadecimal. So we're starting the transition now to assembly language programming, and I think the first step in that process is doing some assembly by hand. So we're going to hand assemble this code using what we know, the opcodes that we've sort of hardwired into our Logisim circuit. So we've filled out this first row with the opcode. It's 10 for load into the accumulator, and to verify that, you know that you've this is the instruction decoder in your Lab 10 circuit, and perhaps you haven't memorized what all of the binary codes are, but that's no big deal. You just look at this and you go, oh, this is inverted. That means this byte has to be high. Well, so that's 10 is load. So so I put 10 for the opcode on the first step, and then it says, oh, by the way you read this after this three-letter mnemonic is to from. So what's before the comma is the to, and what comes after the comma is from. So load to the accumulator from what is at the address of result plus 1. And you'll notice that these are labels. This is another one of the cool things about assembly language, is we can assign labels to hexadecimal address locations. So we don't have to use these numbers when we're trying to remember what mailbox essentially we want to load to or from. We can just use the label instead. And we can also use labels as references for our jump instructions, which is very useful. Another fringe benefit of doing this is if I decide to add some code later, for example, I want to add some code after line 9, then that's going to change it's going to push all these one down, but my labels will still point to the place where I want them to be. So that's another reason to use labels instead of the actual numbers. The other thing I've pre-filled into this chart is the high order address byte, because you see we're writing a pretty small program. We will not have any need to go into address number 128 or higher. So we're going, all of our address bytes are going to, high order address bytes are going to be 00, which should make this exercise a little bit easier. Okay, so just completing this first line. Loading into the accumulator, what is at the address? These little brackets mean at the address of result plus 1. Well, this is the result label which refers to this address, 0035H, and result plus 1 is 0035H plus 1, which is 0036H. So this is what is stored at result plus 1. So I take this value. You'll notice across the top here, these are the starting values before we've done anything. Right? This is a program that's going to multiply whatever's in this address times whatever's in this address. So we're going to multiply A7 by 3. So this is the whole point of the program, is multiplying A7 by 3. Okay, so what I've written here are the initial contents of these memory addresses, and we're going to keep track of that in these columns. Notice how all these columns, num1, num2, and result are correspond to these labels here. Okay, so loading result plus 1, which is 0, 0, into the accumulator. So I'm updating the value of the accumulator, so that's why it's yellow, and I put a 0, 0 there. Now the next line, ADD means add, so adding to the accumulator, the result's going to go in the accumulator, from num1 plus 1. So here's num1, 0, 0, num1 plus 1, the lower order address byte is A7. So I'm going to add A7 to whatever's in the accumulator. First of all, I need to see what the opcode is for add. So you go back to your machine, you say add, okay, that's inverting the third byte, that's this one. So looks like 20 is the opcode for add. So I can put 20H for hexadecimal. Let's see, the num1 is 0031 and num1 plus 1 is 0032. So I put a 32 hexadecimal here. Okay, and when I add the contents of num1 plus 1, which is A7, to 0, I get A7. So now A7 is in the accumulator. Whenever you have an add or subtract operation, you're going to update the values of the 0 flag and the carry flag. Remember, the 0 flag looks at the output of your adder and sees if it's 0 or not. If it's 0, the 0 flag will be high, will be 1. And also, we look at the carry flag as a result of any subtract or add operation. If the carry flag is high, you should put a 1 there, or if it's 0, you should put a 0 there. In this case, the 0 flag is still 0 because it's not 0, and the carry flag is 0 because there's no carry. Great. So the next step is STO, means store, or you also see store A for store into the accumulator. That's misleading, I think. Anyway, because this is the 2, it's going to result plus 1, which means it's going here. So right now I have an A7 in the accumulator, and I'm going to put that in the result plus 1 address. So that means this field now becomes an A7. Nothing else changes. Let's see, store, going back to your Logisim circuit, maybe you remember, store is 1, 1. Right, because this and this are inverted. So 1, 1 is the machine opcode for store. And that's going into result plus 1, which is 0036H. Perfect. I'll just do a few more of these and then ask you to fill out the rest. Loading to the accumulator what's in result, so result is 0, 0, so I'm going to put a 0 there. Load is 1, 0 each, and the result is 0, 0, 3, 5. Nothing else changes there, right? We're just putting what's in the accumulator into the result address, so nothing else changes. On this row, add with carry. Going back to my Logisim circuit, add with carry means this bit and this bit have to be inverted. That's that and that. So that's 22, add with carry. That's my machine code for ADC. And it's we're going from num1, so we're adding into the accumulator the contents of this num1 address. Num1 refers to address 0031H, so low order byte is 31H. And when I add with carry what's in the accumulator to what's in num1, num1 is just 0, so and the carry flag is 0, so this would be 0, 0. My 0 flag is high because the result is 0 and the carry flag is 0. Hopefully you get the idea now. You can, if you want, you can collapse this, and it might actually be collapsed in the version that you have, because this is, it's just a, you'll notice that sequentially this comes after this, right? This is 3, each of these is incremented by 3 until you get to the actual data storage. That's because it takes three memory addresses to store this, to execute this instruction. Remember, we're talking about a 4-step instruction fetch cycle where 3 of those steps are getting the opcode, step 1, getting the high order address byte, step 2, getting the low order address byte, step 3. So this is going to take the first 3 memory addresses. That's why it's 0000H, and then the next one would be 0003H, because 00, 01, and 02 are taken up with these 3 instructions, instruction plus address. Great. Well, if you have any questions, please text or call, and I encourage you to get this done before next Tuesday so that you will have plenty of time to work on your final exam. Thank you.